So now that we have come up with an alternative representation, we will see how we can use that representation to implement. Again, we're going to look at Python code. So again, we have the same three functions, and there are going to be only minor changes. The logic remains absolutely the same. The actual code or the words changes a little bit. So this time in your is valid stage, you have this array called coords. So this array, I'm going to call it coords, which stands for coordinates, and the current row. You don't need the column thing anymore because your array is going to have the column coordinates only, and you don't even need the n value because coords is an array of length n. So if you use len of array, you can find out n value. So the only inputs this function needs are the coords array itself and which row you are at currently. Now again, you do the same thing. You check if there is a queen in the same column. It's just logic. Instead of going through the n squared matrix, using the array alone, I'm checking. So I'm sure if you look through the code, you'll be able to understand the logic. I'm not going to spend too much time on it. So we check if there is a queen in the same column. We check along the diagonals. If any of these conditions happens to be satisfied, it will return false because it is possible that there will be an attack if you place a queen there. If none of the constraints are violated, it will return a true. And then we have generate states, which as usual, irrespective of what your inputs are, what your representation is, it is simply going to return all possible candidates, which again is 0, 1, 2, 3 up to n minus 1. We have our solutions, which is right now an empty array. And then we have our backtrack function. Again, we use this copy, deep copy thing. Again, if you reach the end, it's the same thing. You append a deep copy of this array. So instead of the board, you're going to use a copy of this array called coords. Otherwise, if you are in some intermediate state, you will again generate each candidate. If it is valid, you will okay, so initially we'll put coords of row equals candidate. So what it means is, in this coords array, for the ith row, we put the jth column value. So in place of the third index, for example, we put the number 4, meaning in the column number 3, in the row number 3, we have a queen at column number 4. So you place a column, and then if it is valid, you continue to backtrack, you move to the next subsequent rows and so on. And once everything is done in your board implementation, you removed that, right? So you did board of I of j equals false or something to remove that queen. So here, instead of a false, because this is an integer array, we put a minus 1. The logic is the same. If it's an intermediate state, you generate all candidates. You set one of those candidates as the column coordinate corresponding to your current row. You backtrack, reach up to the last row, come back, and then set that row as minus 1. Again, you iterate, go to the next candidate, you rinse and repeat. So that's the logic. This again is your main function. You take n as input. Coords is initialized with minus 1. So like your initial board was full of false. So here we put minus 1 to indicate that there is no queen in that row so far. You call the backtracks function again starting from 0th row. And once you have the answers, these are. So if you look at this, this will correspond with the solutions you found over here. So it is 1, 3, 0, 2, which is what we have here as well. And this will correspond with the other valid solution you got. So this tells us that this is another implementation which will also give us the right answers if it is coded right.